Section 3.5, page 19. All right, we have another example where we are finding our end behavior using the limit as x approaches positive infinity. If you've not tried one of these on your own, now is a good time to pause, try it, and see what you come up with. So the highest degree of the denominator is the square. So on my problem, I will divide the numerator and denominator by the x squared. Then our denominator, x squared over, it'll be x squared. So when we do our limit, our simplified limit will be x cubed and x squared reduced to 4x. That's minus 1 over x squared. That reduces to 1 and 4 over x squared. So as we evaluate our limit on the denominator, it's 1 plus 0. The minus 1 over x squared is 0. But what about the 4x? The limit as x goes to infinity of 4x. So 4x, as x gets larger, is actually going to be going towards positive infinity. So I can think of that value as infinity. So infinity minus 0 divided by 1 will equal positive infinity. So in this case, there is no horizontal asymptote because it does not go towards a specific number. It goes towards infinity. There is no horizontal asymptote. All right, so now we're going to change it up from just our traditional rational functions. We're going to have a function that contains a radical in our denominator. So in this type of problem, okay, I'm going to rewrite my limit to the right and then go down. So the limit, x goes to infinity. Now when we decide what is the highest degree of our denominator, well, we have a radical. So I can think of this as square root of x squared. So in my problem, I'm dividing my numerator by square root of x squared. In my denominator, I had x squared plus 4. And I'm going to divide this whole radical by square root of x squared. Now for my numerator, I can rewrite square root of x squared as just an x. So I'm going to say 4x over x. And same with the 1 over x. On bottom, I'm going to use the property of algebra, which if you think back to our properties of algebra, we have one that told us that square root of a divided by square root of b is square root of a over b. I can put the two numbers in the fraction inside the radical. So when I do that here, I'm going to have x squared plus 4 over x squared. And it's all underneath the one radical. So on my limit, the top becomes 4 minus 1 over x. And on bottom, I have a square root still, but I have x squared over x squared, which is 1. And then 4 over x squared. So we've rewritten our limit like this, and we're actually now ready to evaluate our limit. So the limit of 4 is 4. Limit of 1 over x is 0. Then we have square root of limit of 1 is 1. Limit of 4 over x squared is 0. So our denominator still has the square root. Because remember, one of our properties of limits, if you take the limit of a square root or any root, you can take the root of the limit of the inside. So 4 on top, square root of 1 is 1. So this is equal to 4. That's the value of our limit.